Hello folks, today we will see how to write an ARM assembly language program to multiply two 16-bit binary numbers. I have referred many YouTube tutorials on this, but most of them have multiplied either two 16-bit decimal numbers or two 16-bit hexadecimal numbers. But how actually to execute this task in a right way? Let us explore that in this video. First, let me show you two of the commonly seen approaches for this task. Coming to the first one, this is the program in which to the R5 register number 77 is moved and to the R6 register number 55 is moved. As you can observe here, these two numbers are the decimal numbers and we are simply multiplying them to get the result in the R1 register. Let me execute this program in the Keel IDE. Open the Keel IDE, create a new Microvision project, select the destination folder, select the target processor. Now create a new notepad that type in the program and save this file in the same folder. Give the extension as yes. Now add this file to the source group 1. Now if I build it, I'll be getting 0 errors and 0 warnings. Let me execute this program. As you can observe here, if I execute the instructions one by one, 77 is moved to the R5 register. Its equivalent hexadecimal value is 4D. Similarly, the next number, which is 55, got converted to hexadecimal and loaded to R5 register as 37. Now if I execute this multiplication, I'll be getting the resultant as 108B. So in this way you will be getting the output as multiplied result. But we are simply multiplying two decimal numbers because we are feeding in two decimal numbers into the R5 and R6 registers. But the task given here is multiplication of two 16-bit binary numbers. Let us see another approach to do this task. So this is another approach of writing this program I have seen in the YouTube tutorials. Here to the R5 register we are loading this hexadecimal number AB. Similarly to the R6 register we are loading the hexadecimal number CD. Finally we are multiplying. So as you can observe here, we are simply feeding in two hexadecimal numbers. Let me execute this in the Keel IDE and show it to you. So this is the program I have written. If I save it and build it, 0 errors and 0 warnings. Let me execute this program. If I execute the instructions one by one, first number AB got loaded into the R5 register, which is as it is because the input number is hexadecimal. The next number CD is moved to the R6 register, as you can see here. Now if I multiply this, the resultant value will be available in the R1 register, which is 88EF. But this is also not the right way of executing our task. So let us see how to do this task in a right way. So this is the program. The same registers R5 and R6 I am making use, but I am feeding in the binary numbers. But how to specify the binary numbers? So this is the way you can feed in the binary numbers. It should be specified in this way: hash 2 underscore followed by an 8-bit binary number. Here I am feeding in 8 number of ones, which is nothing but FF. Similarly to the R6 register, I am feeding in binary number, which should be specified in this way: 2 underscore followed by 8 number of binary bits. So this becomes an 8-bit binary number. Next we can multiply this. As a result of that, in the R1 register the resultant will be stored. Let me execute this program and show it to you. So this is the program I have written. Let me save it and build it. So 0 errors and 0 warnings. If I execute this, as you can see, to the R5 register, number FF should be stored. As you can see, in the R5 register, the FF is loaded. Similarly, to the R6 register, FF should be loaded. Now we can multiply this. The resultant of this is FE01, which you can see in the R1 register. So this is the right way of multiplying two binary numbers. But here we are multiplying two 8-bit binary numbers. If I feed in here any binary number which is greater than 8 bits, it will throw the errors. Let me change the first binary number and let me increase it by just 1 bit. Let me save it and build. As you can see, it throws an error: immediate number, this one cannot be represented by 0 to 255. So that is a limit for the movement. How to solve this? The solution for this problem is the solution to our task we have taken, which is nothing but multiplication of two 16-bit binary numbers. So how to do this task? So this is the way we can execute the multiplication of two binary numbers which is 16-bit long. The instruction here we have to use is LDR. Instead of move instruction, LDR R5, equal. This is the way of specifying the binary number as we have seen in the previous program itself. 2 underscore the number of binary bits which represent the target number. Here I am feeding in a 16-bit binary number. If I convert this to hexadecimal, this will be FF. In the similar way, to the R5 register, I am loading in the second 16-bit binary number, which is again FF. Next, I am multiplying this and result will be available in the R1 register. Let me execute this in the Keel IDE. So this is the program I have typed in. If I save it and build it, 0 errors and 0 warnings. Let me execute this and show it to you. The first instruction is R5 loaded with this 16-bit binary number, which got converted into hexadecimal, which is FF. In the similar way, to the R6 register, the second number is loaded, which is again FF. Next, I can multiply this and the result will be available in the R1 register, which is a 32-bit result. The 32-bit result of multiplication of these two numbers is FFFE0001. So this is the right way of feeding in two 16-bit binary numbers, and we can use it for multiplication. Hope this video is helpful to you. If you like this video, please like and subscribe to my channel. Thank you.